Hi everyone, I'm thrilled to announce the release of the iOS-XE 17.13.1, brimming with feature enhancements, hardware enablement, and solution updates for Catalyst switching. I'm Aisha, a technical marketing engineer at the Cisco's Catalyst Switching BU, and I'm excited to dive into the latest and most noteworthy updates that will be positively impacting your network. Let's explore together. Before we begin, let's take a look at the Catalyst 9000 portfolio. As we all know, Catalyst 9000 switching portfolio, right from access all the way to the core, offer a comprehensive and diverse range of features and solutions, catering to a wide spectrum of networking requirements. And to help maintain and enhance all these features, we at Cisco follow various release cycles throughout the year. Every year, we introduce a major release known as the Extended Maintenance Release, providing 36 months of support. Additionally, every 4 months, we release a standard maintenance release, which is what our iOS-XE 17.13.1 is, and offer 12 months of support. Let's now move on to all the new updates for Catalyst 9000 switching. To help navigate through this, we have categorized all the features and hardware enhancements in iOS-XE 17.13.1 into 4 buckets that we will be analyzing individually. Starting off with platform and infra enablement, we have a series of new hardware introduced that include line cards and optics. Addressing the diverse connectivity needs of today's networking infrastructure, hyper-density and speed at your core is essential for enhancing network performance. In line with this, we are excited to introduce an all-new C9600X LC56YL4C line card for your Catalyst 9600X, featuring 56 ports of 10 gig, 25 gig, 50 gig, plus 4 ports of 40 gig and 100 gig. This is a unique line card that is designed with 3 rows of ports that is capable of providing up to 3.2 terabits per second of bandwidth. Lastly, it supports LAN as well as WAN MACsec, and it is also hardware-based IPsec capable, wherein the software support can be included later. Moving on to what's new in Catalyst 9400 series is that we have added the C9400 LC48TX line card. This offers 48 ports of 10 gig multi-gigabit for data-only scenarios. This is specifically tailored for customers who do not require PoE capabilities. To further support high-speed data transmissions, we have also added a new range of optics aimed for the Catalyst 9300 and 9300X network modules. With the commitment of delivering a seamless and consistent user experience across our Catalyst switching portfolio, we have introduced few network feature additions on certain platforms to ensure parity. Firstly, we have introduced BGP support that includes eBGP and iBGP on the Catalyst 9200CX, accommodating both IPv4 and IPv6. This VRF Lite-based feature provides customers with the flexibility to deploy Catalyst 9200CX switches for both simple branch as well as campus-level BGP deployments. As of iOS-XE 17.12, Catalyst 9500X and 9600X SOUP 2 featuring the Silicon One Q200 ASIC do not support Cisco TrustSec with Cisco metadata SGT propagation through a CMD header in the Ethernet frame, commonly known as inline tagging. However, from iOS-XE 17.13.1, customers transitioning to Silicon One-based platforms can now leverage SGTs in inline tagging for a more granular and context-aware approach to network security. Ensuring robust switch security is essential for safeguarding the entire IT infrastructure. With that said, let's move on to security updates. The Catalyst 9300X and 9400X support hardware-based IPsec encryption and have now undergone enhancements on their tunnel scale capacity. With the evolving network growth, we have elevated the IPsec tunnel scale to 480 IPv4 tunnels and 240 IPv6 tunnels per device, providing users secure and efficient data transmissions across their networks. This enhancement enables customers to place their 9300X or 9400X as a centralized hub to accommodate a larger remote workforce with heightened security. We have also introduced management traffic control, a feature to enhance security by mitigating the risk associated with accepting packets from interfaces that shouldn't be sending management packets to the local switch in the first case. With this feature, management traffic is permitted to only user-defined physical interfaces, preventing ingress attempts from other interfaces on the switch. This ensures a more secure environment, preventing unauthorized access. Notably, this functionality can be easily enabled through minimal CLI configurations, avoiding the need of configuring security ACLs for all interfaces. Now, tracking deny permit actions in SG ACLs poses a challenge. Unlike traditional ACLs, which have enhanced logging generating specific log messages for permit deny actions without significant impact on CPU and memory, SG ACLs lack support for enhanced logging. Resorting to traditional logging in SG ACLs imposes a considerable stress on the CPU and memory. But now, to effectively track actions, NetFlow is employed to capture permit or deny actions when packets hit an SG ACL entry. That way, monitoring of SG ACL drops on a per-device basis will help gain granular insights into security incidents. Let's now move on to some enhanced fabric overlay updates in MPLS and BGP EVPN. In MPLS, we have introduced multicast connectivity to MPLS VPN sites spanning multiple autonomous systems. Taking this network architecture as an example, a customer edge source linked to the provider edge router seeks to transmit multicast data from AS65000 to AS65001, where a customer edge receiver is situated. Internally, within AS65000, iBGP facilitates the exchange of VPN v4 customer routes. To extend these routes to AS651, MP-eBGP enables the exchange of multicast traffic through a separate multicast domain. Within the local AS, BGP VPN v4 routes containing accepted routes within the specific VRF instances are advertised by the provider edge PE. ASBRs play a pivotal role in redistributing BGP VPN v4 routes between the autonomous systems. During this redistribution, the ASBRs alter the next hop attribute to its own IP address, ensuring proper forwarding within the local AS. This enhancement aims to expand multicast coverage for customers who require multicast to extend across multiple sites in an MPLS Layer 3 VPN service. Additionally, it facilitates the consolidation of an existing MVPN service with another MVPN service. Lastly, this is supported in all our UADP-based platforms. As we all know, BGP EVPN provides a scalable solution to build different Layer 3 and Layer 2 overlay topologies over existing infrastructure. And with a lot of customers migrating to IPv6, we want to bring in IPv6 support for our Fabric solutions too. IPv6 underlay support for EVPN Fabric was introduced in iOS-XE 17.11. In that release, we started supporting Unicast IPv4 overlay and Unicast IPv6 overlay. And from iOS-XE 17.12.1, IPv4 overlay multicast to transport on existing IPv6 underlay was added to EVPN portfolio. So what's new in 17.13.1 is that we have introduced IPv6 overlay multicast to be transported on existing IPv6 underlay, thereby offering flexibility and customization to customers to carefully plan and design their network fabric. In our pursuit of establishing a robust zero trust environment within the BGP EVPN fabric, we have introduced a solution, BGP EVPN IPv6 Neighbor Discovery Proxy. This innovative approach is designed to meet the specific demands of channeling all traffic through the gateway for a stateful inspection by a centralized firewall. Let's imagine a scenario where in a BGP EVPN fabric among the leaf devices, host 1 needs to go ahead and communicate with host 2 where both of them are in the same L2 domain, here VLAN 11. To apply the solution, there are a few configuration updates that need to be done. On the host device, we need to set up protective VLANs on layer 2 switches to force traffic, including NDP, to the centralized gateway. Then we need to disable flooding suppression to allow all control traffic to reach the central gateway. Lastly, on the centralized gateway device, IPv6 neighbor routing proxy and DAT proxy is set up on the EVPN VLAN. Once configured, host 1's traffic that is intended to reach host 2 will be directed to the centralized gateway, which is then sent to a centralized firewall for stateful inspection and sent back to the gateway. The gateway then sends it across to host 2. A point to be noted here is that this can be implemented in both fabric and non-fabric environments. Additionally, for BGP EVPN, we have done some CLI simplifications. where for L2 overlay provisioning, currently what is needed is users creating the global config, defining the MAC VRF, L2 VNIs, and all the VLAN mapping. Instead, we have simplified the config. Highlighted in purple are the new CLI changes. Here we are auto-creating the RT, profile, and MAC VRF, and the L2 VNI mapping is dynamically getting allocated. Additionally, this is backward compatible with the existing CLI model. Similarly, for L3 overlay provisioning, we have CLI simplifications done. Currently, what needs to be configured is the IP VRF, L3 VNI, and you need to manually configure the core VLANs as well as the core SVI. Instead, we have reduced the lines of config. Here it is doing an auto RD, and along with that, it is also auto-generating the RT. The rest of the CLIs like L3 VNI, core VLAN, and SVI are dynamically created once we define the VRF. Again, this is backward compatible with the existing CLI model. Transitioning to our final segment, let's delve into the latest advancements in endpoint services and programmability. In endpoint services, we have some significant enhancements to our campus Bonjour solution. With the introduction of AirDrop MDNS protocol support in iOS-XE 17.13.1, we can now seamlessly airdrop content over local and wide area Bonjour networks, eliminating the need for Bluetooth. The recipients of any airdrop initiation hold the power to accept or decline the request. These advancements signify a more secure and user-friendly era of collaboration on our campus. Additionally, we're happy to announce remote MDNS service caching capabilities to Catalyst 9000 series switches in SDG agent or service peer roles. Traditionally, our Catalyst switches manage MDNS cache within the local Bonjour domain. However, for wide area network Bonjour domains, a Catalyst center was essential in order to maintain a service list of permitted MDNS services. In the event of a Catalyst center outage, service interruption would occur. But with iOS-XE 17.13.1, we have extended MDNS service caching to the wide area Bonjour domain within SDG agent and service peers. This ensures the wide area MDNS protocol cache is locally present within the switches. Consequently, the data plane continues transmitting MDNS data even if the Catalyst Center loses service routing connection due to network outages or software upgrades. This innovation brings in several benefits, including swift remote service discovery responses, instantaneous caching of AirPlay and AirPrint service types, and continuous service proxy functionality despite disruption to the Catalyst 9000 switches connection with the Catalyst Center. Lastly, to ensure smooth transition to the next generation network management frameworks, we have a range of new additions of Yang Suite and SNMP mappings for various features available as listed here. To wrap things up, let's take a swift glance at all the features that we have introduced in iOS-XE 17.13.1 for Catalyst 9000 switching. In addition to all the features discussed, we have AAA server MIB support to monitor connections between your switch and ICE, as well as GRE over IPsec for Catalyst 9400X with VRF support. And with that, I bring this session to a close. Thank you for tuning in. I trust you found this content valuable. Please like and subscribe to our YouTube channel.